In this video, I'll show you some examples of closed intervals, open intervals, and half closed or half open. In simple terms, a closed interval represents all possible numbers in a particular set. For example, the numbers 1, 2, 3, and 4 can be represented by this set. Or we can represent it with a closed interval inside brackets. More formally, the definition of a closed interval is an interval that includes all of its limits. Intervals are designated by writing the start point and end point as an ordered pair. Square brackets show an endpoint is included in the interval. So the closed interval beginning at x and ending at y would be denoted x, y within closed brackets. Intervals which begin or end at infinity can't include the endpoint, so standard parentheses are used. But since the limit is included in the interval, they can still be closed. An interval is more precisely defined as a set of real numbers, so that for any two numbers a and b, any number c that lies between them is also included in the set. If the starting and ending point of the interval are finite numbers, these are included in the interval. Finite there means bounded. You can think of it as the opposite of infinite. If either the start or end point is infinite, the interval can't be said to contain its end point or start point, but if it does contain its limit point, it still can be closed. Open intervals are defined as those which don't include their endpoints. For example, let's say you had a number, we'll call it x, which lies somewhere between 0 and 100. The open interval would be 0, 100 inside parentheses. If this were a closed interval and included the endpoints, we would write that in brackets. Closed and open intervals complement each other, but they aren't mutually exclusive. In other words, they can overlap. The empty interval and the interval containing all the reals are actually both open and closed at the same time. An interval which includes one limit and not the other is half closed. If it includes one endpoint and not the other, it's half open. With a closed interval, the endpoints are included in the interval. For an open interval, the endpoints are excluded. So a half-closed interval is sort of like a mixture. One endpoint is in the interval and one endpoint is not. Since we denote an open interval by parentheses and a closed interval by brackets, we denote a half-closed interval by a mixture of the two notations. Imagine your interval has endpoints a and b. If a is included and b is not, we can say the interval is a, b with a bracket next to a because it's included and a parentheses next to b because it's not. If we have the other way around and b is included and a isn't, then we write that as a parentheses for a because a is not in the interval and a bracket around b because b is in the interval. It all looks like mismatched brackets, but it's really just a clever way of denoting which side is in the interval and which side is not. Here we have a closed interval. Note the closed circle and the number line. That represents it's a closed interval. For the second example, we have open circles. These don't include the endpoints, so we use parentheses. These next two examples are half closed or half open. For example, a is included as an endpoint, but b is not. There's one more way of denoting intervals which you may not have come across yet, with backward square brackets. Using that notation, your half-closed intervals become bracket a, and then for b, instead of using a parentheses to indicate it's not in the interval, we use a backward bracket. This next example shows that a is not in the interval and b is. Using set notation, we can define these phrases a little more precisely. When we're talking about half-closed or half-open intervals, you may be wondering when to use each one. The answer is, it's your choice. So what does an optimist call a half-empty glass of water? An optimist would call a half-empty glass of water half full. The same principle works here. And an interval like a, b with the half-closed and half-open, we can call this interval half-closed or half-open, your call. How could we express x is greater than 3 in interval notation? Let's plot it on the number line first. X is greater than 3 but not equal to 3. So we use an open circle on the number line. That tells us that 3 is not in the interval. Our interval is greater than 3, so we shade to the right of the number line. In interval notation, 3 is not included, so we use an open parenthesis. This goes all the way to infinity, and I'll close that interval with a parenthesis. What about if x is greater than or equal to 2? Here we have a closed circle on the number line because 2 is included in the interval. We start with a square bracket because that end of the interval is included. The interval goes to infinity, so we end with a parenthesis again. I hope you found the video helpful. Please take a moment to subscribe to my channel, and I'll see you in the next video.